Now here we are going to solve some numericals in module 2, which is nothing but elastic properties of materials. In a stretching experiment, the extension produced in a wire for lead of 1.5 kgs is 0.2 into 10 to the power of minus 2 meters. The length of the wire is 2 meters and the radius is 0.013 into 10 to the power of minus 2 meters. Find the Young's modulus of a wire. Here given length L is 2 meters, X extension produced is 0.2 into 10 to the power of minus 2 meters and radius of the wire is nothing but 0.13 into 10 to the power of minus 2 and mass is 1.5 kgs. So here we are going to calculate the value of Y. So y is equal to FL by AX. We know that Young's modulus is nothing but longitudinal stress by longitudinal strain, which is nothing but F by A by change X by L. So rearranging the terms, y is equal to FL by AX, where A is the area of cross section, which is given by pi r square. And we know that F is equal to M into G. So substituting both the values of A and F is equal to mg into the equation y is equal to FL by AX, you will be getting y is equal to mgl by pi r square into x. Since m is given, g is we know 9.8 and L is 2 and pi is a constant value, r is nothing but value given 0.013 into 10 to the power of minus 2 and the value of x is also given. Substituting the values using the calculator, calculate it and get the value. Y is equal to 2.77 into 10 to the power of 11 Newton per meter square, which is nothing but a Y. Next problem. Calculate the force required to produce extension of 1 mm in a steel wire of length 2 meters and diameter 1 mm if the Y is given as 2 into 10 to the power of 11 Newton per meter square. Here what is been given? Length is 2 meters. Diameter is 1 mm and the extension produced is also 1 mm and y is given as 2 into 10 to the power of 11 Newton per meter square. So here we are going to calculate F. In the previous problem you have calculated the y with the given values. Here we are going to calculate the value of F. Here radius is been given. Radius is not been given. Diameter is given as 1 mm. Convert the diameter 1 mm into meters, that is 10 to the power of minus 3 and extension is also 1 mm. Convert into millimeters. Millimeters is given, convert into meters, that is 10 to the power of minus 3. Now radius is diameter by 2. So D is given, calculate R. So R is nothing but D by 2, that is 0.5 into 10 to the power of minus 3. So Fy is equal to FL by AX, where A is the area of cross section, which is nothing but pi r square. Rearranging the formula, F is equal to YAX by L. Y is given, A is nothing but pi r square and X is given, L is also given. Substitute all the values using the calculator, calculate the values and the value of F is, we have got it as 78.54. The next numerical. Calculate the extension produced in a wire of length 2 meters and radius 0.013 into 10 to the power of minus 2 meters due to force of 14.7 Newton applied along its length. Given Young's modulus of a material of a wire is y is equal to 2 into 10 to the power of 11 Newton per meter square. Given length is 2 meters. R is given as 0.013 into 10 to the power of minus 2. F is 14.7 and y is also given as 2 into 10 to the power of 11 Newton per meter square. Here you are going to calculate the value of x, which is nothing but extension. In the previous problems for the same values you are not given the value of y, so you have calculated y. Later f has to be calculated. Now x has to be calculated with the other values given. Now we know that Young's modulus y is equal to FL by AX, where A is the area of cross section. So rearranging the terms, x is the extension, and we have to find the extension produced. So x is equal to fl by pi r square into y, which is nothing but f value. Substitute the values which are given over here. F value is given, L is given, pi is constant, and r is given. Calculate the value of x. Using the calculator, you can get the value of x as 2.6 into 10 to the power of minus 3 meter. So this is the extension produced. In previous problems, you have calculated y. In another problem, you have calculated f. Now you have calculated the value of x with the other values given. Next is calculate the torque required to twist a wire of 1.5 meters, radius 0.045 into 10 to the power of minus 2 meters through an angle of pi by 45 radians. If the value of rigidity modulus of the material of a wire is 8.3 into 10 to the power of 10 Newton per meter square. Now here the value of L is given as 1.5 and R is given as 0.045 into 10 to the power of minus 2. Theta is given by pi by 45 and eta is given as rigidity modulus. Eta is given as 2 into 10 to the power of 11 Newton per meter square. We have to calculate the torque tau. So we know that using the formula, couple per unit twist of a torsion of a cylinder is given by C is equal to pi eta r power 4 by 2L. Since pi is constant, eta is given, r is been given and L is been given. Calculate the couple per unit twist. Using the calculator, you will be getting the value as 2.8357 into 10 to the power of minus 3. Now torque tau is equal to C into theta as per the expression we have derived in the theory classes. Tau is equal to C into theta. C value is given and theta value here it is given as pi by 45. Using calculator, do the calculations. You will be getting as tau as 1.98 into 10 to the power of minus 4 Newton meter. Next we go with the another numerical. Calculate the angular twist of a wire of length 0.3 meters, radius 0.2 into 10 to the power of minus 3 meters when the torque of 5 into 10 to the power of minus 4 Newton per Newton meter is applied. Rigidity modulus of a material of the wire is given as 8 into 10 to the power of 10 Newton per meter square. Now here in this problem, what is been given? Length L is been given as 0.3 meters and R is given as 0.2 into 10 to the power of minus 3 and torque is also given here 5 into 10 to the power of minus 4 Newton meter and rigidity modulus is also given. So you have to calculate the value of theta. This is similar to the previous problem. There theta has been given, we have calculated tau. Now tau is been given, we have to calculate theta. So tau is equal to C theta, where C is nothing but pi eta r power 4 by 2L, where C is the couple per unit twist. So rearranging the terms from the two equations, substituting the values of C into tau equation, you will be getting tau is equal to pi eta r power 4 by 2L into theta. Rearranging the terms and substituting the given values, using the calculator, do the calculations and get the value of theta as 0.75 radians. Now another numerical. A rod of cross-sectional area 1 centimeter into 1 centimeter is rigidly planted into the earth vertically. A string which can withstand a maximum tension of 2 kgs is tied to the upper end of a rod and pulled horizontally. If the length of the rod from the ground is 2 meters, calculate the distance through which its upper end is displaced just before the string snaps. Y is given as 2 into 10 to the power of 11 Newton per meter square and G is given as 9.8 meters per second. Now here what is been given here is the rod of the cross section area 1 into 1. That means breadth into the depth L into B is given as 10 to the power of minus 2 meters. 1 centimeter means it is 10 to the power of minus 2 meters. And M is given as 2 kgs, L is given as 2 meters. Here it is length is 2 meters and Y is given as 2 into 10 to the power of 11 Newton per meter square and G is been given as 9.8 meters per second square. So distance through which the upper end is displayed before the string snaps. That means you have to calculate the y naught. What is the extension produced? It is nothing but y naught. You have to calculate it, and this is similar to the equation of a single cantilever. Y is equal to 4w cube by y naught b d cube, because one part of the string is fixed and the other part is fixed, and the tension is given to the upper part, so it is nothing but a single cantilever. So we are determining the Young's modulus of a string. So here we are going to calculate the amount of displacement. We are going to calculate the y naught. So y naught is nothing but 4w cube by y b d cube. Rearranging the terms in the above formula, and all the values, w is nothing but mg, l is given already 2 meters, y is also given, breadth is given as 10 to the power of minus 2, and d is nothing but 10 to the power of minus 2, because l and d both are the same, that is 10 to the power of minus 2. So substituting all the values into this equation, you will be getting the value of y naught as 0.314 meters. Thank you.